In today's weekend video, we'll be looking at the Jackery solar generator. This is going to be the Explorer 1000 V2 version. And I finally got the solar generator because the features finally matched, the design matched, and the price around the Black Friday mark here in the US dropped considerably, which enabled me to go ahead and buy it. This was not a sponsored video. I did not get it from Jackery. This is something that I purchased myself. But the reason I did it and the reason I'm showing this video is because three things are coming together. A, we have a good set of features. B, it is finally using lithium iron phosphate versus lithium ion itself. And three, the price point. Now it makes it reasonable to go ahead and get this unit. We'll talk about the features here in just a second, but essentially, when it's lithium iron phosphate, you're getting over 3 to 5,000 life cycles, which changes the usability of this product considerably. From the packaging side, packaged really well, no issues, no concerns there. It came in without any dings or holes in the unit, which was worrisome to make sure that that's the case because you don't want to be damaging those batteries in shipping. Quickly looking at the ports perspective, we do have one DC 12 volt port on this unit that will use kind of car charger style ports, cigarette lighter styles. We have two USB-C ports, one at 30 watt rated, the other one is at 100 watt rated. And then we have one USB-A port rated at 18 watts. We can enable or disable those ports as needed using this button DC USB. On the right, we have the AC button here, and that enables the three AC outlets. Combined, they can output total of 1500 watts. We have a light button for enabling three modes, which you can cycle through, which I'll show you that in a second. On the right here, we can charge the unit through obviously the appliance, your electrical power grid cord, or you can do that using solar, and the connectors here are using 8mm barrel style connectors. This unit is shipped obviously with some charge, but they can't charge it fully for obviously legal reasons. So it is shipped at 29% charge. And here's the list of all of the technical specifications. Instead of boring you and reading them one line at a time, I'll let you pause this video and then you can read those out for those who are interested in some of those details. I really like the folding handle that they have here in their revised design, and also the silicone grip that helps you carry this unit so you don't have a whole bunch of plastic digging into your hand when you need to carry it. So that is very nice and convenient. So doing the very first charge on this unit, I went ahead and plugged it in and turning it on, looks like it's powering on. And from the 29% mark, it is starting to charge at about 350, 360 watts of power to start that charge. They do have the hours right below it, which means it gives you an estimate of when this unit will be charged. And at this rate, you'll get 2.4 hours. So one of the cool features with this unit is that you can control some of your settings via the app and customize the unit functionalities the way you want it to, which is awesome. One downside of all of this is that you do need to have an online access and register an account with Jackery in order to move forward and add this unit into the app. There is no way to manage this unit without having online registration. Important to note in case you want to manage it when you are somewhere off grid, perhaps, well, that's not the time to start registering because it's not going to work. But once you're in and you add the device into your app, from that point forward, you don't need internet access because then you can just manage it either through Bluetooth or Wi-Fi. But to get that unit added into the app, you do need internet and online access. Once everything is added and you're in the app, you get very good data and statistics in terms of the input power that is coming in, whether it's solar or AC. You'll be able to see how much output power you're drawing out of that unit. You'll be able to control the AC ports and the DC ports to turn them on or off. And also you can control the light if you want it to be low, medium, high, etc. And here are some of the settings you're able to change and configure from the app. Again, you can pause the screen if you need to look at this in more detail. In the battery settings menu, you're able to choose whether you want to use the battery fully, which means it's going to use 0 to 100%, or you can put it into a battery savings mode, where in this case, the unit will power off at 15% and also will stop charging at 85%, therefore increasing the life of your battery over multiple cycles over time. And there's also energy saving mode where you can select after how many hours you would like the unit to automatically power off if there is no output or no load used on that unit. And there is a section for firmware updates in case there are any updates in the future. Something that I would have loved to see in the app that is kind of missing is battery health status information, something along the lines of how many charge cycles, discharge cycles that we have. Is there any battery cell information, health perspective? Any of this data would have been really nice and helpful here. For example, in my DJI app for my drone, it lets me look up at the battery and see if all of the cells are balanced, for example, and that helps me gauge the status and the health of that battery. Having this information within the app here would have been really cool, but unfortunately, that information is not here. There is a fan running when the unit is being charged using the regular settings, but it's not loud at all. If you have any other noise in the room, you can't hear it, but they do have a silent mode where the fan does not run. And then it charges and it's quiet. But either of those modes, I have no issues either whatsoever. It charges just fine without any problems. So now that the unit has been charged to 100%, we can do some real world testing. And by real world testing, I mean I would like to push it to the limit. In reality, in real world, of course, I'm not going to be boiling a whole bunch of electric kettles on this thing. But for this test, I would like to see if it is able to use a large amount of power draw to see if it will work. This unit is rated for 1500 watts on the AC side. This is what I would like to test with using the kettle. I know it's going to draw a whole bunch of power, it's going to drain the unit quite a bit, but the reason I'm doing this test is to see if it can power those type of devices. Specifically in my case is if we have a power outage and my refrigerator's compressor, for the first few seconds does require a lot of power draw, and then it comes back down really low. It needs 40 to 80 watts, but the initial draw is going to be much higher than this. So I would like to see if this unit can handle those high draws. According to specification, it can handle a constant draw of 1500 watts with a peak of 3000 watts, which means in reality, anything reasonable that we're going to throw at it, it should be able to handle it just fine. So from the power draw perspective, 1400 watts looks like no issues whatsoever. It is working just fine, no concerns there, so it is within that 1500 rated wattage being used. On the left, with my TP-Link power tracker here, you can see it's being updated. The top row is the information that we are looking for. The bottom one that has the extra days does not matter. So because it is winter time here, it did take a little longer for me to get this kettle to the boil aspect. From the percentage, it dropped to 81%, which honestly did surprise me a bit, because if I look at the power draw on the TP-Link app tracking site, and again, so far when I use it, it's been very accurate. It's only used a tenth of a kilowatt, so about 0.9 or 10% of the unit's total power. So that 81% did surprise me a little bit, but let's do other tests and see cumulatively, is it going to have any issues? And are we going to get to that close to the rated aspect of 1070 watt hours? Next test is we're going to use with a toaster oven. And again, yes, in the real world, I won't be using toaster oven with this unit, but from the power draw perspective, I'm going to do that test. That brings us up to using 1496 watts of power maximum from the toaster oven. And yeah, when we elevate the wattage usage, we do hear the fans in the Jackery come on for ventilation, obviously, but it is able to handle those units, those watts just fine. No issues there from that perspective. I will say that the total kilowatt usage on the right is not updating as often in that app as the live watt usage on the left. So something to keep in mind that I do need to sometimes exit out of it and then go back in to see the total usage being used. And it's able to handle the toaster oven just fine, no issues at close to 1500 watts here. From the Jackery saying we're down to 69%, that's still a little lower than the 0.22 usage that we had reported by the TP-Link. So I don't know if that 69% is truly accurate, but let's do other tests and see how far we get. So this next test is a pretty big test, and that is going to be to see how is the refrigerator able to work off that unit, which is one of the reasons why I got it, is to power it in case during we have power outages. Initial draw of the compressor is what kicks out most of the other lower end power kind of generators, etc. The initial load of the compressor is what's important. Generally, my refrigerator works between 40 and 80 watts of power when it just does its regular cooling, so to speak. But the initial compressor takes more power, and lower end solar generators or any generators may have issues handling it. In this case, it was able to handle it without any issues. It goes to around 400 watts, less than 30 seconds, and goes back to that initial startup process and then goes off, on and on. So I left this unit on for multiple hours, just let it draw power and see how things go, and also then after that to monitor to make sure that there are no issues starting up the compressor. And again, this specific unit was able to handle it just fine. So about 3 hours later or so, after it ran for a while, we got down to 42% according to Jackery. And from the power tracking perspective, looks like we used 0.44 of a kilowatt. So now the battery percentage is still a little off, but now we're getting closer in line and I think more reasonable to what we're using versus the battery percentage. So we used, over 50% or so, or close to 50% power. Alrighty. Next test here is we're going to test it with a heat gun. At this point, I'm really not expecting any issues, but I'm just doing capacity testing, load testing, trying to throw various things at it to see if there are going to be any issues. But given that we already had the kettle, we already had the toaster oven, we're pretty much not going to go over that 1500 watt of rated power, but I'm going to test both settings. The lower setting here is going to be at 7 to 800 watts, and then the second faster setting is going to be at 14 to 1500 watts according to that heat gun. So we'll test both of those out for just a couple of minutes. I'm not going to put the entire video here, but I'll show you the quick test that I've done there. And then I ended up at zero point 0.7 kilowatt usage with that heat gun cumulatively with all of our tests so far. The next test that I wanted to do is connect an Instapot, again, a high power draw item. We know we're not going to be, again, using a whole bunch of Instapot all the time with this unit. But again, from the power draw and capacity testing, I just wanted to continue doing that test. Something that you will see in line that right now we use 0.7 of a kilowatt, which is rough, 700 watt hours out of the 1070 rated, and we're at 39%. So now the battery percentage remaining is starting to match much closer to real world usage. Initially, I got scared with that, 81% drop at after the very first test. Here with Instapot, we can see it is using 950 watts or so to 1,000 watts. And the way they work, they're actually, even though they use high draw initially, it's going to take maybe 6-7 minutes or so for it to get to that, up to 10 minutes maybe, to get to that pressure point. Once it's at that pressure point, the power actually is going to drop to zero, and it's only going to kick on to keep up that pressure. So let's say we're going to turn on the unit for 15 minutes. We're not using 15 minutes of power. We may be using 5 to 10 minutes of power, depending on how much stuff you have in that Instapot. And because it is wintertime here, the water is cold. I had 4 cups of cold water and 2 cups of grain in the Instapot, which means that it did take a little longer than I was thinking to get to that pressure point. But once we were at that pressure point, the unit just cycles on and off periodically to keep up with that pressure. I'm just going to fast forward here to save time. And at the end, you will see that cumulatively we got up to using 0.87 kilowatt for all of our tests so far, as I said, as a cumulative test. And we're at 19% battery remaining. That gets us really close to the rated capacity. So now numbers are actually matching, and I'm fairly comfortable with them. Next test here was not necessarily for load, but just to drain some of the battery power. So I did plug in my HEPA air filter device and just let it run. I have 3 settings there, low, medium, high. One discovery in this test that I made is that if it is a relatively low load, the output screen on the Jackery says 0 watt is being used, and that's not quite the case. So 3 watts, it did not register it. I'm going into the second setting here, and we're pulling about between 7 and 8 watts of power, and the Jackery output screen still says 0 watts. So it looks like it's not registering a lower end power draw. So it is something to keep in mind if somebody's going to use the settings for, hey, turn this device off if you have no power. Well, for low power devices, this setting may not work well because it will turn off that unit if you're enabling it. Now here we're at 44.5 watts, 47 watts, and of course Jackery is registering it no problem at that point. So something to keep in mind that their display may not be 100% accurate on that power draw for lower type of loads. Here we're using 7.5 watts, and yeah, it's still reading 0. So something to keep in mind. Next test here is just going to continue to drain the battery further, and I'm going to plug in a portable refrigerator cooler that can work from either AC or the 12-port side. Again, since I'm doing capacity testing here, I'm going to run down the battery on the AC side because it's going to take a little more power. But I'm already relatively comfortable with the numbers we're getting, so I'm not going to take it all the way down to 0 simply because there is no need to damage battery cells when it has extremely low battery capacity remaining. Numbers wise, I'm already comfortable where we're at. Right now we're at 0.89 kilowatt used and 16% remaining. And by the time I finished doing this test, we were at 0.92 kilowatt used and 11% battery remaining. So 0.92 is 920 watt hours out of the 1070 rated capacity. I'm comfortable with this. There is no reason to take it down to 0 damage battery cells. Again, I paid for this unit. It's not a review unit, so there is no reason to do that in this case. Tomorrow should be fun. I looked at the weather forecast for Sunday, and we're going to get some very sunny skies, and we're going to charge up this unit with some new solar panels that I got for it. This is a 200-watt portable solar panel that folds essentially into kind of one piece. These are non-Jackery. These are another brand, Ugreen. I'll do a separate review on those. Jackery solar panels were just completely overpriced. Even at 50% off, they would be highly overpriced. But the Jackery solar generator unit does have two 8mm barrel style connectors. My Ugreen solar panels came with an XT60 connectors, so I needed to get an adapter. Just keep in mind, if you're going to do this, there are male adapters, female adapters, so make sure you get the right cable for your panel. In my case, because the Ugreen were female adapt ends on both ends, so I got an 8mm DC barrel to XT60 male connector in order for this to work and connect. So from those 200-watt solar panels, at the moment we're getting 167 watts, which is, I think, fair, given that, again, it's winter time, so hopefully around summertime we'll get some more sun and maybe better results. But even at 167, I'm fairly happy with that. Over time, it says that from 11% charge, it will take 6.4 hours to get things charged up. Obviously, I may not have enough time during the daytime. It gets dark at about 4:30 here, so it's not going to get charged up that way. In this test, we get up to 33%, and I'm testing if I can charge and use the AC at the same time, and we can, not an issue. And when we turn the AC on or off, you'll see the input uh, hours aspect is going to get updated in order to get to the full size to 100%. So obviously when I was doing an output of 100 watts, it takes way longer to charge it back up, and those numbers will update. So without me using any output, it took 5.7 hours. If I'm going to start taking output, that means I'm inputting 163 watts in and taking 110 watts out, right? It's going to take way longer to charge the battery back up. Next test here is going to be powering on the chainsaw and the compressor. The chainsaw electric wattage motor may be using about 1,000 watts or so, but the startup will always generally use a little bit more. I would like to see if this power unit will be able to handle it. Same thing with the compressor. And we can see no issues running the electric chainsaw. Metering wise, on the meter, it does use at about 1,000 watts or so at its peak time frame. And now we'll be testing the compressor and getting that to start up, see if it starts up. It does well on the startup, no issues that I can hear when it's starting up. It's going to get to 950 watts or so, and then it's going to peak at about 1200 watts cumulatively because I'm also charging the DJI controller, I'm charging some batteries, and just making sure that there are no issues and it is able to handle it just fine. And the reason you're seeing zero input power, even though it is plugged into solar, is because I'm charging the battery preservation setting to ensure it doesn't charge when the battery is already near to being full. As part of my testing, I did email Jackery with a list of questions, and by the end of the day, I actually was surprised that I got all of the answers that I was looking for, and some of them were fairly technical. One of the items I was inquiring about is if I'm using both an input of solar and an output, is if there is any bypass of energy going from the solar straight to the inverter without going into the battery first. And they confirmed that unfortunately that is not the case. So if I'm putting 163 watts in and taking 110 watts out, the 163 will go straight into the battery first before my 110 go out. It would be cool if they had a inverter bypass feature where if you're taking output of enabled on the unit, it would be really cool if it could go through bypass and then only deposit the extra energy that the solar panels are generating. Unfortunately, that's not the case. I don't think that is that big of a deal because, again, there is still an inverter there that lets us do what we need to do. It just would have been cool to have a bypass mode from solar directly into AC and then only deposit or withdraw the extra power that you need. But that's all right. But they were able to respond the same day, answer all of my technical questions, and some of them were, as I said, quite out there. And I was very happy to get a response. Clearly without any issues. And again, it was a same day response, so very happy with that. The rest of it is going to be longevity wise. We'll see how things work. I'll keep updates in the comments over the years to come, and hopefully we'll get many happy years out of this unit. Thanks everybody for watching this video. I hope you have found it helpful and beneficial. Take care. Bye bye.